On our Dare to Compare tour today, we're going to take a closer look at Goodman's commercial products line. This line goes up to 20 tons in size, and I'm told that we'll discover why Goodman commercial products offer outstanding curb appeal. Joining me is Bill Miller. Hello, Bill. How are you?
Mark, good to see you.
Good to see you. What's the first thing on our tour today?
We're going to see the assembly of our light commercial product that we make here at the Fayetteville plant.
Great. And where are we starting here?
Starting on our first line that builds the smaller tonnages. We build 3 through 6 tons on this line. We have another line that builds 7.5 through 12.5 tons. And then we have a work cell that's building a 15 and a 20-ton unit.
What was the biggest innovation that you discovered doing that?
Well, we got the dealers, the distributors in. We had them in a warehouse. We asked the dealers, what do you like about this unit? What do you dislike about this unit? And taking all the inputs, we put everything we could that customers like about the design of a product into our product so that we felt we'd have the best design in the industry. Another thing that we found out from them, if we wanted to really be efficient for them, there's a certain size of a curb for light commercial units, a curb size. Thousands of them out there. Guess what? We designed our unit to fit that curb like a glove. So if you got a job site where you got an old worn out unit, you can buy a Goodman unit, you can take the unit off, and you can put the Goodman unit off with no extra curb, just a little insulation.
Wow.
And it's really helped our sales.
That's a really smart innovation.
It's very smart to listen to your customer.
Sure is. All right, well, let's get on with the tour.
Let's go see it. As we go down the assembly line, you can see that the cabinet is taking shape here.
Right.
This is the indoor section. This is the outdoor section.
Okay.
Again, we talk to our customers. What's most important? And insulating the indoor section is very important.
Absolutely.
This is a weld gun. It actually has a weld pin that we weld the insulation to the interior panels so it can't come loose. We retain it on the outside edges, so that insulation is there to stay, never to fail in the product.
That's great.
Mark, the vast majority of our package units are package electric cool and natural gas heat.
Okay.
What you see here is a burner manifold assembly.
Right.
And this particular burner manifold assembly has 4 different burner tubes. We have 3, 4, 5, and 6 different burner tubes. The more tubes, the more capacity for heat. The beauty of doing everything yourself is we can build to order with very short lead times. Here you see in the unit the complete heat exchanger. And I might point out that we use the same tubular design with a wrinkle bend.
Right, the wrinkle bend technology.
That we use in our residential. We've got a heat exchanger that's gone over 2 million cycles without a failure. That's the best quality heat exchanger in the industry.
I bet.
And there you see it installed in a unit. This is where the unit gets its identity.
Okay.
This online printer is tied into our scheduling system, and this is the serial plate for the unit.
Okay.
This has the model number, the serial number, all of the different specifications, and all the barcoding information that identify this unit down the assembly line. But at this point, that unit has a name.
Right.
It's got a serial number, and that's how we track it from here on. In addition, this station is the first station in our critical component scanning process.
Okay.
Critical component scanning is a computer-based system that's tied into our master bill of material files that when this operator scans that serial plate, it tells him what that model number is, what the serial number is, then he scans the compressor and it tells him that's the right compressor for that unit. In addition, this goes into a master database so that this model and that serial number has a database file that keeps the serial number of that compressor so we know right where they went. As you can see, the evaporator coil is already installed, and the condenser coil, this operator across the line is using an assist device to bring the condenser coil over and set in the unit. The compressor is outside of the coil.
Right.
Some of the designs put the compressor inside the condenser coil, where it's extremely difficult to get to. You almost have to disassemble the whole thing.
Right.
This part of the assembly line is where all of the interconnecting tubing to the coils have been installed and brazed together, and we're getting ready to put the indoor blower assembly. If you notice the blower assembly table, she's got a scan gun as well, because this blower motor is a critical component to the operation of the unit. Okay, Mark, we're at the point of the line now where we've got a complete refrigeration system.
Right.
It's all brazed together. We've done a high pressure burst test to make sure there's no weak spots in the system.
Sure.
Then one of the most important elements of making sure you've got an effective refrigeration system is the evacuation of any moisture or any contaminants.
Right.
You see overhead, we've got these vacuum pumps that move along with the line. You see that gauge up there? The vacuum has to be drawn down to 100 microns or better, because having a clean system before we charge it with refrigerant is the key to quality. This is the charge board station. This is where the unit is charged with the precise amount of refrigerant. The way the operator does that, take the serial plate, scan the serial plate. No human intervention, no typing in a serial number.
Right.
The computer automatically reads what the serial number and model number it is. It's automatically programmed to put the exact number of ounces of refrigerant that goes in that particular model. For quality of the product, it's got to be right. Okay, the unit has been charged with refrigerant, and the coils were tested for leaks in the coil shop.
Right.
But we did do some brazing along the line here.
Right.
And as you well know, a leak in a unit is a dead unit. So at this point, we have an online leak detector, and this operator goes by every single joint to make sure that that refrigerant system doesn't have a leak in it. We've got a refrigerant system all evacuated and charged, but we need something to control the unit. And this is the control panel.
So these all get tracked just like all the other critical components?
These all get tracked, and that scan gun over there tells them that they're putting the right parts in the unit, so it's always built right. Okay, Mark, we're at the run test station, and this operator is our run tester. Right now she's doing a high pot test, which is a high voltage, low current test to make sure there's no loss to ground. There's no shorts in the unit anywhere. When we did do our customer research, single side servicing was very important. What I mean by single side servicing is, you see, you got the control panel on this side, you got the compressor on this side, you got the blower motor on this side. Everything can be done from one side of the unit.
Sure.
Customers told us one of the big problems they had with other designs is you had the control panel on that side, everything else on this side, so you'd activate on that side, come around on this side to see if it worked. Now she's hooking up the gas line. Now she's hooking up the high voltage electrical. Of course, there's no power to those lines right now. And you'll notice on the contactor, another thing our customers told us, they like lugs. They don't like other types of electrical connections. Those provide very positive electrical contact for the incoming electrical lines. Next, she'll hook up the low voltage connections that provide information from the thermostat. Let me point out one thing before she starts the run test. You see this label that we put inside the control box?
Yes.
That has the model number and serial number. This serial plate that goes on the outside, after 10 years of sunlight, you can't read that.
Right.
I don't care what label there is, by what manufacturer. Our customers told us it's very important that they are able to identify the model and serial number of the unit no matter how old the unit is. So we responded, and we put a little sticker that's got the model and serial number inside the control box where it'll never be wiped out by sunlight.
That's great.
She's scanning the model and serial number, it's feeding into the computer, and now the computer takes over. It's turning on the gas, and it's got a completely pre-programmed test cycle. The blowers come on. Now the important thing about a run test that's controlled by computer is this particular model has all of the run test parameters programmed into that computer. When it goes through the test, it needs to draw the right amount of current when this blower's on. It needs to draw the right amount of current when the compressor's activated.
Right.
If it doesn't run within the preset parameters of the run test, it'll fail. And the fail record will be stored in the computer. The operator doesn't have to make a decision at all. Everything's done by the computer.
Wow.
I've talked all along the line about critical component scanning, the test record. See that passed right there, where it says passed? That computer has recorded a past test record for this serial number. Now, the only way a unit can get shipped is for a traveler that has the barcode, that has the serial number and the model number, to be printed and put on the box. Otherwise, my shipping department has no way of identifying the unit that they pick up.
Sure.
The only way a traveler can be printed on this printer is the operator scans the unit, and it's got to have every single critical component record in the database, and it's got to have a past test record. So it's an error-proof process. We cannot ship a unit that hasn't had everything done correctly.
That's great.
End of the line.
End of the line. So we've
she is.
Made it through all the testing, and we've got the Traveler printed, right?
That's correct.
Okay, does this get boxed up like the other products do?
No, these are designed to go outside. That's got a paint system that's got an epoxy primer, and it's got an acrylic top coat. It's going to last for years outside. Why waste the money to put a cardboard box on it?
Tough, you don't need a box.
There she goes, handled with tender love and care.
Absolutely.
Let's go on to the next line, and we'll see the next bigger size chassis being built.
Can't wait to see it.
All right. This chassis runs 7.5 to 12.5 tons. Again, some of the same concepts and principles that went into the design of this product that I mentioned on the smaller,
right?
Same thing.
Same thing.
Designed the footprint to match existing curbs. All of our 7.5 and higher have 2 refrigerant systems.
Right.
Customers told us it's very important in a commercial application, if they have anything wrong with a unit, that if they just have one side go down and still have some cooling, they can keep their business running.
Sure.
We listen to our customer, and every design unit 7.5 and up has 2 equal size systems so that it can always be in operation. Also, all of the quality systems you saw on line 3, the smaller tonnages, repeated here. Every critical component is scanned, every unit gets an evac and charge by computer, every unit gets a run test, and we can't print a Traveler on this line until all the database is filled and the run test passed record is in the system. Let's go see how this thing goes together. Okay, Mark, you can see the units coming together. We've got the gas heat exchanger installed in the unit now. We've got the evaporator coil. Control panel was just set here, and this gentleman is wiring it up. All the wires go through grommets so they don't get frayed by the sharp metal. And the control panel assembly table is right over here. Same concept of critical component scanning. All of the circuit board, the capacitors, the contactors.
Each and every one.
Each and every one gets scanned in. Make sure it's the right one, and make sure we've got a record of what went into the unit. Hope you can hear me. This is the run test.
Right.
Now these units are bigger units, 7.5 to 12.5 tons. This run test has a duration of 7 minutes. We programmed every possibility of error failure into the run test on this to make absolutely sure that once this gets a passed run test record, there's nothing possible wrong with it. Okay, are you ready for the granddaddy of them all?
The big one?
The 20-ton unit.
Let's go see it.
Let's go see it.
Wow, Bill, you said this was big, but this is really gigantic. How big is this thing?
Well, I got out a tape measure, and it's about 20 square feet bigger than my office. It weighs over 2,000 pounds, but it's 20 tons of efficient cooling.
No kidding. Wow, that is truly the granddaddy of them all, isn't it?
Yeah, and even though it's 20 tons, and even though we build it on a smaller line, all of the quality procedures you saw on the smaller units apply to this.
Right, same testing,
Same testing, same critical component scanning. Every quality standard applies to every size unit Goodman builds.
Wow. Thanks, Bill. I thought that was a great tour.
Great. Thank you.
Today we've enjoyed a quick overview of the Goodman line of commercial products. It's quite impressive to note the attention to detail, the continuous quality enhancements, and all the testing. Not to forget the curb appeal of the units, too. It all adds up to an outstanding product line, one that you need to visit in person to truly experience this operation. So what are you waiting for? Schedule your own Dare to Compare tour today.